All right, this is AP BC Calculus. We're doing a BC only section. This is 10-2, working with geometric series. So let's jump right into what a geometric series is. So a series in which the ratio of consecutive terms is a constant r is called geometric. So you'll see this written one of a couple ways. So one common way to write this is that we have this a at the front as a constant, right? And then you're multiplying by r each time to get to the next term. So times r, right? So a times r again would give you an ar squared, and then times r again would give you an ar cubed, and so on and so on. You can sometimes also see this, instead of starting at 0, starting at 1, where the r is to the n minus 1 instead. So you'll see the same thing, and you can see that if you plug in 1, you'd get exactly the same thing. You'd get an a, and then you'd get an a times r to the first when you plug in n as 2, and then you get an a times r to the second when you plug in n as 3, etc., right? So you can see it written in either of these two ways. In either case, a is that first term in the series, right? Okay, so let's review to determine if each series is geometric. If it is, we're going to find r. If it's not, we're just going to say it's not. So for this series, I am subtracting 5 to get to the next term, right? So this is not geometric, right? So this is actually called arithmetic, which doesn't help us in calculus, right? So this is actually arithmetic for the record. It is not geometric, right? So geometric means you're multiplying by the same number or dividing by the same number to get from one term to the next. So in this case, right, to get from 900 to 300, I could, specifically negative 300, I could try dividing by negative 3 or timesing by a negative 1/3. Let's see if that works, right? If I do 900 times a negative 1/3, and then if I do negative 300 times a negative 1/3, right, if I multiply by a negative 1/3, sure enough, that gives me 100, and if I multiply again by a negative 1/3, sure enough, that gives me a negative 100 over 3. So yes, this is geometric, and r is a negative 1/3. One way to see that, if you're having trouble doing it, just drawing it the way that I did, is that you can actually do a ratio of one term, right, over the term before it, which is a negative 1/3. And you can see that that ratio holds up, because 100 over a negative 300 would also be a negative 1/3. And if you did negative 100 over 3 over a positive 100, that would also be a negative 1/3. So that's the ratio is negative 1/3. So here, this one is also geometric, and you can see that just by the setup here, right? So what I'm multiplying by every time is a 7 over 8. And if you wrote some of these terms out, you'd see that when you plug in n as 1, you get a negative 2, right? Because this would be a negative 2 times this thing to the 0, right? When you plug in n is 2, you get a negative 2 times a 7/8. So that's a negative 14/8, or you could write that just as a negative 2 times a 7/8, right? When you plug in negative 2 times 7/8 to the, now it'll be a 2, right? You'd get a negative 2 times a 7/8 quantity squared. So what you're multiplying every time by is a 7/8. It is geometric, okay? That is geometric. All right, so let's go ahead and try the same thing here, right? You're going to see if something's geometric. Again, this is a review of pre-calc, right? So this one is geometric, and you can kind of see that just by the setup, right? So this is definitely this is my A, and this is my R, right? So if you could just see that without writing it out, you can see that, hey, this is geometric. I'm multiplying by a negative 3/2, right? This one is not geometric. This is arithmetic. I'm adding 2 every time, right? So this is actually called arithmetic. And you didn't have to know that. You just need to know that it's not geometric. Okay, not geometric. And then with this one, to get from 1/8 to 1/2, right, there's a couple different ways you can do this. You could say, hey, what do I have to multiply 1/8 by to get to 1/2? And it's multiplied by 4, and you can see if that holds up, because 1/2 times 4 would give you 4/2, which is 2. 2 times 4 gives you 8. So it seems that what I'm doing is multiplying by 4 every time, right? Multiply by 4, multiply by 4, and you can check and see if that holds up. The other way to do it is to just make a ratio of the new term over the previous term, which is 4, and you can see if that ratio holds up. And it does, right? If you do the, 2 over a negative, over a regular 1/2 would be 2 times 2 over 1, which is also a 4. So you can see that this is geometric, and the thing you're multiplying by is 4. So when we look at geometric series that are infinite, what we'll find is that they're fairly easy to spot, right? So geometric series are one of the easiest type of infinite series to deal with, because they're pretty easy to spot. We saw that you can also, as I wrote early on in a previous slide, it can look like this, but it's the same idea. You've got some r to a power, you've got a number in front. The other reason they're super friendly is because they have a pretty simple rule to remember what they converge to. We really just need to know the value of r. So if r is less than, if the absolute value of r is less than 1, then the series converges. If the absolute value of r is greater than 1, then the series diverges. So basically, and if r is a 1, then it's actually not a geometric series, right? So we can actually, this is one of the only series where we can actually find the value that it converges to, which is rare. We can't usually do that. So if a geometric series has an r value that is, an absolute value of r is less than 1, then the series converges specifically to a over 1 minus r. If a series has an r value such that r is greater than or just greater than 1 or equal to 1, but it wouldn't be geometric if it was 1, then the series diverges, right? Because if you're multiplying by 1 every time, it's not actually a geometric series. All right, so let's go ahead and walk through. So determine if the series converges. If it does converge, we want to say what it converges to. Well, we've already seen this one before. We figured out that this r is a negative 1/3. We saw this in a previous example. Right. So my first term, right, my first term is 900. My r is a negative 1/3. So since the absolute value of negative 1/3 is less than 1, it converges, definitely converges. And then more specifically, it's going to converge to a over 1 minus r. So that's going to be a 900 over a 1 plus 1/3. That's a 900 over a 4/3, right, because it's 3/3 plus 1/3. So 900 over 1 times 3 over 4 should give me a 2700 over 4. Right, which is not it's not a super small number, but it doesn't have to be a super small number. It's a finite number, right? For P2, we've seen this one before also, right? We're multiplying by 4 to get from one term to the next, so my r is 4, right? This is geometric, but since the absolute value of 4 is greater than 1, this thing diverges, and there's no more work to do, so diverges. All right, we'll try one more here. So now it's written in this series notation, right? So it can be helpful to write out the first couple terms. If you plug in n is 1, you're going to get a 5 times this negative 3/2 to the 0. So the first term is just a 5, right? And then what's going to happen is the thing I'm multiplying by every time is a negative 3/2, right? So this would be a negative 15/2, right, when I plug in the next one. So my a is 5, but my r, right, my r means that this thing's going to diverge because the absolute value of negative 3/2 is greater than 1, so this thing diverges. Now, if you can just see that without listing any terms, that's fine. Here, right, this is my, let's list a couple terms just to make it really obvious what your a value is, right? So if I plug in n is 1, I get a negative 2 times a 1, right? So it seems that my a is just that first term, right? Plus the next term is going to be this negative 2 times a 7/8, right, et cetera, et cetera, et cetera. So my radius, or sorry, my ratio rather, my r is 7/8. Well, the absolute value of 7/8 is less than 1, so this thing converges to a over 1 minus r. So that's going to be a negative 2 over, this is 8/8 minus 7/8, so it's a 1/8. So I'm going to get a negative 16, right, because this is negative 2 times 8 over 1, which is a negative 16. All right, so real quick before we end this video, we're going to do the obligatory math joke. Okay, so infinite mathematicians walk into a bar. The first mathematician says, I want a pint. The second mathematician says, give me half a pint. The third mathematician says, give me a quarter of a pint. The fourth mathematician says, give me an eighth of a pint. And then the bartender says, whoa, 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 hold on, fills 2 glasses full, right, and says, know your limits. So you get it, it's an infinite series joke because this, right, this is a series where we're summing from essentially 1 to infinity of, if you count the first mathematician as 1, of a times, there's my r to the n minus 1, right? The first person walks in and asks for a 1, right? The second person asks for a half. This is a geometric series, right? So this is a geometric series where a is 1 and r is 1/2. So it's going to sum to a over 1 minus r. That's a 1 over 1/2, which is how we get 2. And you can kind of see the visual of how it works. All of these other mugs, right, the green and the blue and the purple in every mug after, that's slowly but surely going to fill the second mug. So the first mug is already full. That's the yellow one. Anyway, that is our infinite series joke and the end of 10-2.